This is going to be a video for section 2.3.6, which is the learning outcome for El Nino and La Nina. And specifically, I'm also including upwelling here. I'm covering it. You guys already have these words down. But you had current, Coriolis effect, thermohaline circulation, the global conveyor belt, Antarctic circumpolar current, downwelling, upwelling. We're going to see how upwelling is going to be a major factor in El Nino and La Nina. And then the Humboldt current, we'll be talking about the Humboldt current in this section as well. Okay, so we started this section with tides, and then we went into the global conveyor belt and just some general currents, Coriolis effect, and wind. Now we're going to talk a little bit more about the wind when we consider upwelling. And then the very last thing, it's discuss the cause and effect of El Nino and La Nina events during an ENSO oscillation or El Nino Southern Oscillation cycle in the Pacific Ocean. And El Nino and La Nina are like weather and meteorological phenomenons. They don't know why it's caused, but it does. These cycles happen every like 3 to 5 years. Cause is unknown, which is good for us because then we don't have to write that as an answer. All right, so just a little bit about upwelling. This is a good definition to know. Knowing this definition specifically can get you a good deal of marks. So it's the movement, so it's a current, of cold, nutrient-rich water from the seabed to the surface, or deep in the ocean to the surface. Cold, nutrient-rich, got to include the nutrient-rich part, from the deep ocean to the surface or the seabed to the surface. Okay, it's caused by offshore winds, and that's right there what I showed. So the brown area is going to be your shoreline, and offshore winds are winds that are blowing offshore. They're blowing away from the shoreline. What's going to happen is as we start to push these waters away, it's going to create like an overall area of like low water pressure. There's not as much water piling up there. So we have an area of like low water pressure right here. Water wants to take its place. It's just like how particles, molecules, just how materials like work in physics. If there's an area of low pressure, things are going to want to take its place. And so the only place that's going to be able to fill that low water pressure gap is water from the seabed. And that's that water down here. So an area of low water pressure is formed at the surface because the wind has blown that water away from the shore. And so we mentioned nutrients are coming in. I'll delete these extra lines. So nutrients are coming in, but where do they come from? Where are the nutrients even coming from? So they're dissolved nutrients, and they're going to sink to the seabed because they have mass, and if they have mass within the water, then the water is more dense. Dense water sinks. These nutrients are coming from organism waste, like fecal material, dissolved solids from runoff, so just even like fertilizers or dog, animal, pet waste, anything from agricultural runoff to even like residential runoff going into rivers or going into estuaries and into the ocean. So we have a runoff effect. This is also tissues from decaying organisms or organisms that have been consumed, and maybe they're scraps like detritus, scraps that fall out of the mouth of a consumer or a predator. Those things are going to sink to the seabed. And this will be a vocab word in the next chapter, but this is called marine snow because as it sinks to the bottom, it doesn't have really any pigmentation with it. So it just looks like white particulate sinking to the seabed. But marine snow is actually full of nutrients. And these would be similar to like the fertilizers we would put on terrestrial plants, except this is the fertilizer, I suppose, of the sea. And so then the biggest things, we're moving from the abiotic to the biotic cycle. We're moving from the non-living and just wind, water, nutrients into the biotic cycle. So when this is moved up, we're in the photic zone, and that's where our producers are, mainly phytoplankton. We should be thinking about them first. Those are your photosynthetic, microscopic, floating organisms. That was already a vocab word for you. They can take in these nutrients that come up from the seabed and use them to make more biomass, to make more organic material. So glucose, proteins, anything like that. It also allows them to make more of themselves. And it's going to increase producer productivity. Productivity is a rate. It is the rate of glucose production or the rate of photosynthesis. So how fast an organism is doing photosynthesis. So productivity, it is a rate. It should play. It won't play. We'll live with it. We can see this process occurring here. So starting with the first step, we're going to have winds blowing offshore. And I know it looks like it's going to this south direction, but remember, we also have the Coriolis effect. And so in the northern hemisphere, where we are, because this is off the coast of California in this example, water is deflected to the right. So wind is blowing or blowing offshore along the shore. Water gets pushed away. We have this area of low water pressure. At the surface, water is going to want to come and take its place. Kind of like when a new checkout lane opens in the grocery store, people will want to take that place. Like people will go over there and kind of even themselves out. And then your cold, nutrient-rich water from the seabed is going to move up to take that place, and it's cold. So this is why, like off the coast of California, also off the coast of Africa, off the coast of Peru and Ecuador, like we'll see, there's a lot of productivity going on. There's a lot of biodiversity. There's massive whales there. You have like a feeding frenzy because it's just like straight up fertilizer for your producers, and the food chain follows. So if you have a lot of producers, then you're going to have a lot of herbivores, or a lot of primary consumers, first eaters. A lot of primary consumers, you have a lot of secondary consumers. A lot of secondary consumers, a lot of tertiary consumers, and then quaternary consumers. So things follow their food source. Phytoplankton are starting it off. Phyto means leaf-like, plankton means floater. Zooplankton, zoo pertaining to animal. Plankton means floater. These would be like little larvae. You also have some animals that spend their whole life as phytoplankton, like jellyfish. Small fish, larger predators, and then we have like a secondary consumer right here, even a primary consumer, are filter feeding whales. Okay, El Nino and La Nina. Throughout this, I'm going to reference El Nino in like smaller font. It is associated with weak trade winds. So not being sexist when I just try and associate these different phenomenon with different images. La Nina is going to be a very strong trade wind, so the strong female. And then a Luffy. Okay, so before we can talk about El Nino and La Nina, we need to consider what the conditions are normally like, so that when there is a change, like El Nino or La Nina, we can actually compare that to something. So this is going to be what the conditions are normally like. We're going to be really considering the effects off the west coast of South America. by Peru and Ecuador. Okay, so I have this map here. Also on your note page, you also have a map that is similar. Move my extra. On your note page, you have a map that's similar. Follow with my color directions and make sure that we're stating all of the things, especially the things that you think, this is probably a lot of details, we don't need to know this. Because those are the things that are question 1, question 2, 3, 4, 5, you've heard me say this. Okay. The notes are written based off exam material. So if they've asked it once, they can ask it twice. Okay, so this Humboldt current, you had a vocab term for that. It's also called the Peruvian current. It is going to move up off of the coast of South America, the west coast of South America, right here. Okay, so it travels along this coastline. During a normal condition, not El Nino, not La Nina, the Humboldt current is going to flow up along the west coast of South America, and it brings cold, nutrient-rich water towards the equator. And this right here, you can see that the equator is there. There's our equator. Why does this happen? So the only winds we need to know, and I talked about this last week, is the trade winds. So the equatorial trade winds. Equatorial meaning they're about the equator, and they're the winds that are blowing at the equator, period. They are blowing, you need to know normally what's a normal condition. They blow east to west. Okay, they blow in this condition, this direction. East to west. East to west. Okay. And if they're actually doing that, well, then they're going to be blowing water off the coast of Peru. So if we're going in this direction, east to west, we're pushing water off the coast of Peru, off the coast of Ecuador, and that's an offshore wind. Offshore winds produce upwelling because that water is blown off the coast. You have an area of low water pressure. Cold, nutrient-rich water from the seabed is going to move up or upwell to take its place. And along with it is going to be those dissolved nutrients. And so traditionally, this area, because it's by the equator, is very warm. And all of this area of warm water is traditionally right here. Warm water isn't yellow. All this warm water that's usually over here is actually going to get moved away off the coast towards Australia, Asia area. And I'm going to call that Australasia, Australia and Asia. In this picture here, we have all of this warm water piled up over there, and that's because it was over by Peru, but it got pushed over. And that's because of the trade winds blowing east to west along the equator. How did this area get cold? Because we have an area of low water pressure, and cold, nutrient-rich water from the seabed moves up to take its place, and that is called upwelling. So the Humboldt current is actually what's doing the upwelling. Okay, we'll talk about the effects in these different countries. So the effects on the different countries that are on both sides of like the equatorial Pacific. So we just left with there's going to be upwelling from the Humboldt current. We're going to have more producers, mainly phytoplankton. That should always be what we're thinking about in terms of like our go-to producer for the open ocean. It's going to have more productivity. Again, this is the rate of photosynthesis. There's going to be more photosynthesis, or photosynthesis is going to be happening faster due to more nutrient availability. Great. why does this matter? Again, the food chain follows. So if there's more producers, you're going to have more organisms in your different trophic levels. So there's more organism populations in food chains. So every trophic level, if there's more food, there's going to be more in each trophic level. They're all going to increase in population. For example, more phytoplankton mean more zooplankton. Zooplankton are always going to be your primary consumer. They're your first eater. Trophic level 1 is primary producer, so the producer. Trophic level 2 is the first eater, the primary consumer. They're also known as herbivores because they're plant eaters. Trophic level 3 is the secondary consumer, the second eater, and so on. So more phyto, we're going to have more zooplankton, which means we're going to have more fish. Here we go. The sardine population and the anchovy population off the coast of Peru are very common exam questions and good examples that Cambridge likes to use for the effect of El Nino on the marine species and also on the coastal communities, the people that live there. There'll be more seabirds, and we'll see a lot of things like this, like filter feeding whales in the area because they're going to be filter feeding krill and all that plankton material. And if we have more seabirds and more fish, we're going to have more predators as well. So it's a very biodiverse area. This does not happen off the coast of Florida. This is going to result in more money for the fishing industry. It's also referred to as more money for fishers or fisheries. Fisheries is like a fishing company. Fishers is like fisher people, fisher folk, fishermen, fisher women. And it's always another mark. There's going to be more food for human communities. So there's the economic aspect of it, and then like the social aspect of it. So you have job availability. You're going to be making money for your region, and there's going to be food availability for people who live there. We'll also like improve the standard of living in the area. Could bring tourist industries because they want to see whales. Like that would be a good time to do it. So then we have all this warm water again that's blown over to Australasia. Warm water is going to evaporate. It's going to rise into the atmosphere and then it condenses. So evaporation, condensation, just your basic water cycle, and then precipitation. Australasia area is going to have more precipitation because that's where all your warm water is going. That's good for Australia because Australia, time and time again, has crazy wildfires. So this is going to keep that from happening. All right. In Asia, one of their main exports in terms of like a food crop is rice. Rice requires flooding. Rice grows in floodplains. So plains, flat areas, and then there's a flood. It needs to grow in a flooded area. And again, not only is there money for exports, but then there is also food availability for the locals. And South America is going to remain dry. And we'll talk about why that's important too. If you know anything about the coast, the west coast of South America, it's all mountainous. The Andes Mountains are down the coast of Argentina and Chile, and it's very mountainous. When you have a lot of mountains and you have increased rain, couple that with deforestation, which we don't talk about in this class, but that is a reality of what's happening in South America. You have nothing to like hold down that water in the ground. So you have rock slides, you have mudslides, and it's quite devastating. But that's not what's happening here. South America is going to stay dry. So this is all what should be happening in a normal condition. During an El Nino phase, this is referred to as a warming phase because the west coast of Peru is warmer than it would be normally. And it occurs every 3 to 5 years, and it's referred to El Nino as like the boy, because typically they see these phenomenons happening around December, which would be like when we celebrate Jesus' birth. Jesus was a boy, so El Nino means boy, so boy. It's really just referred to like the time of the year when they see this happening. It's referred to as a warming phase. This is a warm current off the coast of Peru. And again, we're always thinking about, well, how is this different from the normal? So in a normal phase, we have the trade winds blowing from from east to west. Normally it's going this direction. And we're getting a lot of upwelling happening off the coast of South America. In El Nino, the trade winds will either slow down. So instead of like this very strong equatorial trade wind blowing from east to west, it ends up being this like little weak wind, like just this little like puff of wind, just tiny little air, just push it, not a lot of energy behind it, pushing water across. But it's not pushing it all the way across when it's weak, just a little tap. Or what you can also see is you see a complete reversal of the trade winds. So instead of them blowing, as we would normally see, from an east to west direction, now it's blowing from a west to east direction. And that's how we see it in this picture here. So you could have a weakening of the trade winds going their normal direction, or it's a complete reversal. Either can happen. In this picture, you see the reversal. This is going to cause warm water to build up off of the coast of Peru and Ecuador in South America. The effects. So warm water and moist air will not move west toward Australasia. Likewise, even if it's weakening winds or it's reversal, you still see where this warm water would have been is getting pushed over to the South America coast. Without the offshore winds blowing west, so without our traditional winds blowing in this direction, we're not going to have any upwelling here. So the Humboldt current is not upwelling. Anyway, pretend like that didn't happen. So talking now about what's going to happen to the different countries. This is a big one. This was a question last year for our time zone. So because there's no upwelling in South America, we could just assume what we wrote about in the normal conditions is not going to happen. We're not going to have any producer productivity due to lack of nutrients coming up from the seabed. This will cause a lack of populations of consumers. So if you don't have a food chain to follow, nothing's going to follow. This will cause a lack of money for fishermen. There'll be a lack of food supply for local villages and just like the local regions there. And fish that are desiring cold water are going to either migrate or die. Remember, warm water doesn't hold gas as well. They need oxygen. This was the question my students had last year. So the effects of no moist air being blown towards Australasia, or it's blown away. And again, in this picture you have it shown as a reversal, so going in the opposite direction, so being blown away. But even when it's not reversed and it's just weak winds, just this little puff of air, it's still not enough. You'll still have the same overall effect. The effects aren't different. This tiny little burst of air is still going to keep warm water off the west coast of South America. So there's a lot of effects here. Australasia is going to experience less precipitation. That'll be a bad thing. There's less rain, so you're going to have like less bad weather events. There will be less tropical cyclones or less typhoons. We call them typhoons when it's happening in the Pacific. When it's the Atlantic, we call them hurricanes or tropical cyclones. They're all tropical cyclones. We're going to have higher air pressure, which not to sound like it's a negative thing. It's not a negative thing. High air pressure is good weather. Low air pressure is bad weather. The lack of precipitation is going to cause more drought conditions and starvation because you're not going to have as many crops grown, especially in Asia. Asia grows those rice crops and they need to have floodplains. And if there's no water from the sky to flood the plains, then you're not going to have any rice. Wildfires. She's already on fire. Wildfires happen often, but this is going to be way more frequent. And because you don't have this like precipitation occurring off the coast of Australia and off the coast of Asia, I think we know in Florida, especially in the summer, when we have like our afternoon thunderstorms, it will cool down just a little bit. The ocean is holding a ton of heat in it. It has a really high heat capacity, and it can release some of that heat to the atmosphere. Well, instead of that happening, there is no precipitation and there is no bad stormy weather here. So any heat that the ocean does have, it is going to stay within the ocean. So Australia is going to experience higher than normal water temperatures. There's really nowhere to release a lot of that like stored pent-up energy. Higher water temperatures is going to result in coral bleaching. So the zooxanthellae that lives inside of the coral polyps, its little photosynthesizer inside of it, is going to expel itself from the coral itself, and that's coral bleaching. If this happens, we're going to have a decrease in coral reef biodiversity, so the different species and the amount of different species in the area, we'll have less of those. There'll be less fish population, and fish are going to migrate to deeper waters. Almost done. Notice the rain clouds that are happening over South America and those countries there, Peru, Argentina, Ecuador. As I mentioned before, it's very mountainous. So the west coast of Peru and the west coast of South America in general is going to have a lot more precipitation. A lot of this warm air is just staying off the coast. Where's my mouse? There it is. Okay. Staying off the coast over here. This is going to cause more flooding, more mudslides. More precipitation could decrease the salinity going off the coast when you have runoff. The stormy water or the stormy weather will produce clouds. The clouds could also decrease light penetration for producers. Okay, so this is the devastation of El Nino, and then we'll finish up with La Nina. All right, I'm actually gonna skip this slide because it's gonna force you to watch the ad with it, and I can't skip through the video, and I also don't want to get copyrighted, so I will post this separate link to your Google Classroom. All right, so just one like last visual. So normal, we have trade winds pushing this warm water off the coast of South America to Australasia. But during El Nino, we can have reversal of these trade winds, and now we have this warm water piling up and warm air over off the coast of South America. And it looks like this. Much more warmer water over here. And it could be the reversal of trade winds, or it could be just the weakening of trade winds. So La Nina actually is not as complex as the El Nino. If you notice, before I look over the notes, the picture I included is a normal year. So this does follow a normal pattern, and there's not any reversal. It's just very, very strong trade winds blowing water across. So we're going to see an exaggeration effect of what would be in a normal situation. We're going to see it's a lot of like very much exaggerated. So this is going to form a cold water current. And these like warm water current, cold water currents, comparisons, those are comparing what the water current's like on the west coast of South America. So Peru, Ecuador. That's where it's like cold or warm, like in comparison to. These are stronger trade winds, stronger than normal conditions. El Nino had weak or reversed trade winds. The stronger trade winds are going to blow more warm water from the surface away from Peru, and it'll cause even more cold water from the seabed to upwell in the Humboldt Current, because if you have an area of low water pressure at the surface, water from the seabed is going to want to take its place. If you have an area of very low water pressure at the surface, a lot more water is going to want to take its place. And so the only difference I did here is I just put on a much bigger arrow. This is going to cause even more upwelling because there's more nutrients, or more upwelling will bring in more nutrients. There'll be more phytoplankton, more producers, which will mean more small fish, more larger fish. We're going to have much more food to feed the local regions. We're going to have a lot more employment options in terms of working in a fishery for the locals. And then just some fun facts. Scientists use what's called an oceanic Nino index to predict El Nino events. I haven't seen this as an exam question. This was just being extra. If there's 5 consecutive 3-month periods with sea surfaces of half a degree Celsius of the average sea surface temperature, it's considered to be an El Nino event if it's above it, just by half a degree for 3 months in a row. That's what they use to predict it. Okay, so we need to kind of focus on the trade winds. What they normally do, they normally blow from east to west. What happens then in terms of upwelling? And then when those get reversed or even weakened, the lack of upwelling. And then La Nina, a much stronger normal version. One last graphic. So again, normal conditions up here, even though you can't see it. El Nino at the bottom. La Nina, much stronger trade winds pushing and piling warm water up off the coast of Australia. El Nino, warm water is piling up off the coast of South America.